Hi there. Today we're going to be doing 4.6, which is negative and zero exponents. So by the end of today's lesson, you should be able to simplify and evaluate powers with a negative exponent and an exponent of zero. So let's just look at a couple of the rules, if you will, of these exponents. And you remember your rules from grade 9. We used all kinds of exponent rules to multiply two powers that had the same base. Remember that? So we had something like this. I'll just give you an example, like 2 cubed divided by 2 cubed. Do you remember that rule? So we're dividing two powers with the same base, and what they told you to do was to subtract the exponent. So this would be 2 to the 3 minus 3, which is 2 to the 0. Well, we didn't give you any of those in grade 9, or we weren't supposed to, because we were supposed to teach you this in grade 10. But 2 to the 0, or in fact anything to the 0, equals 1, as long as the base is not 0. So that's the zero exponent rule. And let's just unpack that a little bit. If you look at this, well, 2 cubed is 8, and 2 cubed on the bottom is 8. So what's 8 divided by 8? Or in fact, what's anything divided by itself? Of course, you know that that is 1. So did it matter if it was 2 cubed? It could have been 5 cubed, could have been 5 to the 6th, as long as the same power is on the top and the bottom. So yes, anything to the 0 equals 1. Now, we'll talk a little more about that in a moment when we do the examples, but for now we'll move on to the negative exponent. So the negative exponent is a little bit trickier. When you have a negative exponent, really, what does that mean? If you think about it, it just means you take your base and you multiply it by itself a negative number of times. That really makes no sense in the context of what you know, right? Because if you had 2 cubed, for instance, you know that that represents 2 multiplied by itself 3 times. And 2 cubed then is 8. Well, we can't multiply a base by itself a negative number of times. So that whole rule for figuring it out with a positive exponent doesn't apply in this case. So we've got to use a new rule, and that is really that what you do is you take the power itself and you bring it to the bottom of a fraction if you have a negative exponent. So I'm going to bring this down, and I'm allowed, when I bring it down, to make it positive. And because I have nothing in the top, I'm going to put a 1 there. Now, it shows as 1 over a to the n, which is the same as 1 over a to the n. Either of these is equivalent, okay? So that's the rule for negative exponents. If I had a negative exponent in the bottom, so let's say I had something like this, 1 over a to the negative n, the same rule applies. I can take the power with the negative exponent, I can move it, in this case, to the top, and in moving it, I'm allowed to change the exponent to a positive. So this would be a to the n over 1, which of course is just a to the n. Okay? So you think about picking up the power and moving it either to the top or the bottom, depending on where it was, and changing the exponent to a positive. And when they get really complicated, I think that rule really does help you to remember, like for instance, if I had 2a to the negative 3, you don't just put the whole thing 1 over 2a cubed. You only take the power, which is a to the negative 3, and you put it in the bottom. So this would be 2 over a cubed. Okay, so you're taking the power and putting it in the bottom. But often, if you only have a power in the top, then you have to put a 1 in its place if there's nothing there. Okay, so we'll keep going here. We'll do some examples. 20 to the 0. Well, that's equal to 1 because the base is 20, the exponent is 0. Negative 1 to the 0, also equal to 1 because the base is negative 1 and it's being put to the 0 exponent. This one, however, is tricky because the base is 5. So the power itself is 5 to the 0, and this is actually saying make that power negative. So the answer to the power, 5 to the 0, is 1, but we want to make it negative according to that. So this answer is negative 1. So you see the difference here between negative 5 to the 0 and what I wrote there, negative 5 to the 0. There's a difference between those two questions. This has an answer of 1 on the top. So this has an answer of 1 because it's negative 5 is the base to the 0. That's 1. Anything, even a negative to the 0 is 1. This is not a negative to the 0. It's only a 5, positive 5 to the 0, and then we're making the answer negative. Okay, there's a big distinction between these brackets, and hopefully in grade 9 you understood the difference between those two. Okay, so this one, negative 4 to the 0 is 1, and then we want to make that negative, so that's negative 1. Okay, fractions. I didn't talk about those, but a fraction to the 0 is the same as any other base. It's 1. So this is 3/4 is our base because the whole thing is in a bracket. So this whole thing becomes 1. This one, however, when you look at it, it's not 3/4 to the 0. It's only 3 to the 0. So this question is really saying, what's 3 to the 0? Take that answer and divide it by 4. So 3 to the 0 is 1, and 1 over 4 is just 1/4. 3 to the 0, of course, is 1, plus 3 to the 1 is 3. And so the answer to this one is 4. And this was just in there, I think, to trick you maybe into forgetting or maybe misapplying a rule for multiplying powers with the same base. Remember, there's a rule from grade 9 that says if you have 2 powers with the same base and you're multiplying them, then you can add the 2 exponents and keep the base the same. But when you're adding them, there is no shortcut rule. You simply have to evaluate each power separately and then add them together. Okay. So let's move on to the negative exponents. 4 to the negative 5 is the same as saying 1 over 4 to the positive 5. And I'm going to need a calculator here. So 4 to the positive 5 is, I don't know, 256, something like that. Let's see. 4 to the 5. Oh, I wasn't even close. 1,024. Oops, it's 1 over 1,024, right? 1 over 1,024. This one, the power is negative 9 to the negative 1. So if I'm going to write that out, I'm going to take the whole power and put it in the basement. And I'm only changing the negative exponent to a positive, so I'm going to have that. Then I'm going to evaluate the power, so 1 over negative 9, or we could put the negative in the front or in the top, right? Really, I mean, that's a better, just to put it in the front. Okay, one thing I want to just caution you about is for these, I don't want you using your calculator to calculate this. Yes, I know you can punch in 4 to the negative 5. Do it right now. 4 to the negative 5 gives you 0.0097, whatever it is. It's not what I want. I want a fraction answer. Remember our general rule, if there are no decimals in the original question, you cannot give me a decimal answer. So these will always be fraction answers. Okay, unless there was an original decimal in the question. So negative 9 to the negative 2 would be 1 over bracket negative 9 squared. It's very important that you have that bracket again. If you just take a quick second to check your own calculator, if you're doing negative 9 squared, negative 9, I'll check my own here. Negative 9 squared gives me positive 81 on my calculator, but on some calculators it would actually give you negative 81, and that's because negative 9 squared is negative 81 because it's 9 squared and then you take the negative of it. So it's really super important that you put your brackets in to distinguish between negative 81 and positive 81. So this is actually 1 over positive 81. Okay, so brackets are super important in these questions. Okay, fractions. So I didn't talk about the rule for fractions, but really super simple. If you have a fraction to a negative exponent, just flip the fraction and you're allowed to then change the exponent to a positive. So I would evaluate this This fraction is saying take the 3 and put it to the 4th, and take the 1 and put it to the 4th. Well, of course, 1 to anything is just 1. 3 to the 4th is 81. So we'll just leave it as simplified as possible at 81. This one says take 2/3 and put it to the negative 3, and then take the negative answer. So I'm going to rewrite that as negative 3 over 2 to the positive 3. And BEDMAS says I can't do this part first. I've got to do the exponent first. So this is going to be negative, just for now do that, 3 cubed over 2 cubed. You don't have to write that part out. If you can figure out what the 3 cubed and 2 cubed are, it's fine. So this is going to be negative 27 over 8. Simplify that if possible, but it's already simplified. So again, this is going to be negative. The negative here does not change when we flip it. So it's still going to be negative 7/6. The only thing that we're allowed to change if we're taking the reciprocal of the fraction is the exponent is allowed to become a positive. So this is going to become negative. A negative to an odd exponent is going to be a negative. So I'm just going to do 7 cubed and 6 cubed. Ooh, I better do that on my calculator. 7 cubed is 343, I think, yeah. So 343, and I'm going to have a negative here somewhere in front. And 6 cubed is 216. So there we go. I have a negative times a negative, no exponent, so I'm allowed to multiply these now, and this is just going to become 343 over 216. I don't think that reduces either. Okay, so that's it for the basics of the zero and negative exponent, but we still have a few more examples that are quite a bit trickier. So let's just see what we can do here. So if we've got, it says determine the value of x that makes each statement true. Well, if I've got x to the negative 3 equals 1 over 125, first of all, I know that because it's negative 3, that I'm going to get likely to get a fraction unless this is some sort of fraction answer, but we're not going to make it that difficult for you. So I'm going to look at this and I'm going to say, all right, well, what about x to the positive 3? Because that's got to equal 125. So x cubed is equal to 125. And I know if I take the cube root of x cubed and the cube root of 125, I'm going to get x equals, and your cube root button is on your calculator somewhere. You just have to find it. It might look like this, x to the 1 over y. It might look like this. There's a variety of things that it might be, and it might be under the second function. It might not be a key on your calculator. So just have a second to find that button. And x cubed, oopsie. So that's going to be 125. Okay, and the answer, of course, is 5. I don't know what the heck I was thinking. Okay, so super easy then. X equals 5. X to the negative 1 equals 11 over 8. Well, that's an interesting one. If we have x to the negative 1, then we can really write that as 1 over x, right? To the positive 1, but why would we write the positive 1? So x over 1 over x equals 11 over 8, and you could like cross multiply, or you just know that the result of this has to be the reciprocal here. So again, it's not guess and check. This was certainly an algebraic method, but when we get into some of these exponents that are variables, it will be more of a guess and check kind of thing. We don't have an algebraic way of solving for this x, but we certainly know that 2 to the something has to give us 1 over 16, and 2 then the x has to be a negative in order to get it to be a smaller number than 2. It has to be a fraction, so we know that that x has to be negative, and 2 to the 4th is 16, so x has to be negative 4. So 2 to the 4 equals 16, so 2 to the negative 4 equals 1 over 16. Okay? And you would just be guessing at that point as to what the numbers are. You're going to use your calculator to figure out the 4. 2 to the something equals 16. You don't know what it is, but you can kind of guess and check on your calculator. Okay, so 4 sevenths to the x equals 49 over 16. Well, if I look at this, 4 to the something equals 49. There is no nice number. 4 squared is 16. 4 cubed is 64. 7 squared is 49. Oh, 7 squared is 49. How interesting. So 7 squared is 49. 4 squared is 16. So I know that this has to get flipped. And the only way to get it flipped is to put a negative exponent in. And the question is, what negative exponent? And we just decided 4 squared was 16, 7 squared was 49. So we know that 4 to the negative 2 equals 49 over 16. And I made a really big boo-boo. Oh, goodness, what happened? Sorry about that. I made a boo-boo here because I really didn't solve for x. So we know here that x equals negative 4, right? That was our solution. Sorry about that. Okay, and so here we would have that x equals negative 2. Okay, let's try the next one. So 9 times 3 to the 2x equals 1 over 729. That's looking a little bit confusing. The first thing I would do is I would get it so that it's just one power on one side and one fraction on the other. So I'm going to divide both sides through by 9. So 9 times 3 to the 2x equals 1 over 729. And I'm just going to change colors here. So this is going to be divided by 9, and this is going to be divided by 9. And some students were having a bit of difficulty. They didn't have trouble with this part, 3 to the 2x. That, of course, just gets rid of the 9s. But over here, they were just dividing 729 by 9. We're dividing this whole fraction by 9. So 1 ABC 729 divided by 9. You're really dividing a fraction into a smaller amount, into ninths. So that fraction is going to even be smaller than it already is. So it's going to be 1 over 65, 61. So all I did here was I had 1 over 729 times 1 over 9, right? You take that the bottom and you flip it in order to divide the two fractions. This is like a fraction, 9 over 1. You flip it, it's 1 over 9. And then you multiply the two fractions. Okay? So hopefully you can get a handle on that. Oh, goodness gracious. I don't know. It must be a swipe or something that I'm doing. Okay. So at this point, we want to solve for x. So what we would do is we would let 2x equal y, so that we're just working with a single variable. So we would have 3 to the y equals 1 over 6, 5, 6, 1. All right, so again with the fraction over here on the right-hand side, we know then that our y is going to be negative because we have to go from a big number of 3 into a smaller number of 1 over 6,561. So the question is, 3 to the what equals 6,561? So I am going to do my guess and check. I'm going to start with, I don't know, 7. No, it's not big enough, so 3 to the 8th. There, 3 to the 8th. But I know it has to be negative 8 equals 1 over 6, 5, 6, 1. So y equals negative 8, but I let y equal 2x. So 2x must be equal to negative 8, and x must be equal to negative 4. Okay? So not that difficult, but again, just a couple things you need to remember. Dividing the fraction makes it even smaller if you're dividing by a whole number. You want to let that exponent, if it's not just an x, you want to let it equal another single variable, and then once you figure out what that variable is, you've got to go back and solve for x. Okay. Last one. Feel free to pause the video here if you want and try it, and then come back. Okay, so we've got 5 to the 3x equals 1 over, and this is going to be 625 times 25, which is a big number, 15,625. And so we're going to let y equal 3x. So 5 to the y equals 1 over 15,625. And now we have to decide 5 to the what equals 15,625. So I'm going to start with like 8 again. That's too big. So 5 to the 7th. Oh, I'm going to plus 5 to the 5th. Okay, 5 to the 6 it is. So 5 to the negative 6 is equal to 1 over 15,625. Same idea here. It had to be a negative number in order for you to get the smaller fraction. And so y equals negative 6, and we had that 3x equals negative 6, so x equals negative 2. Okay? All right, hopefully you got that, and that's it. So go and practice zero and negative exponents, and thanks for listening.